Hi, in this video I will talk about blockchain key terms and we'll get into cryptography in blockchain. So we'll see what is meant by immutability of data, what is the 51% attack, what is cryptography in blockchain and how is it used, cryptographic methods used in blockchain. So what is meant by the immutability of data? Immutability in a blockchain refers to the fact that once data has been recorded, it cannot be changed or modified. This feature is accomplished through the use of cryptographic techniques. These allow the integrity of data to be verified and maintained. Immutability makes a blockchain a suitable platform for storing and sharing important information and helps to ensure that the data can be trusted as it cannot be altered. So, for example, we have a blockchain in one of the computers, and this computer can be your computer, your system as well. You can download the data for a public blockchain, right? And another computer can have the same data, and another one can have the same data as well. Since data is same on all of the blockchains, for the first one, for the second one, for the third one, and it can be thousands of blockchains, computers, we assume that it is immutable. I will also have a blockchain demo as I mentioned in the previous video, and you will understand immutability in detail and in action. So what if data is changed on one of the computers? If you try to change the data on one of the computers in a blockchain network, the change would not be accepted by the other computers in the network. This is because each computer in the network has a copy of the blockchain, and they all work together to validate new transactions and maintain the integrity of the data. For example, one computer has the blockchain and the other one has the same blockchain, and in the third one there is a change made by some malicious actors. So in this regard, the majority will be considered as valid because we are 2 and you are 1, and you are not gonna be considered as valid. So this makes blockchain really secure. But what if we have the majority on most of the computers on the network? So in this regard, we need to understand 51% attack. If malicious actors were able to take control of the majority of the computers on a blockchain network, they could potentially manipulate the network in various ways. This is known as a 51% attack, as the attackers would need to control more than 50% of the network's computing power to carry out such an attack. So for example, we have a blockchain and it's not changed, but the majority of the blockchains is changed by some malicious actors. So in this regard, they have the majority of the computers, and even if one of the computers has the correct data, we can say that okay, majority will be considered as valid, and even if this data is changed, it cannot be assumed that it's changed. But that's not practically possible, because in this example we have 3 blockchains, 3 computers, but in a blockchain network like Bitcoin blockchain, there can be thousands of computers who have the same blockchain, and changing data at the same time with the same information on all of the blockchains is not possible. So that's why we assume that the system is really secure and it's distributed. It's not on a specific place. Everyone can have it, and it can be thousands of computers. Okay, so what is cryptography? Cryptography is the practice of creating and using codes and ciphers to protect information from unauthorized access or manipulation. We'll see cryptographic terms in detail, so you don't need to worry about, for example, cipher if you don't know it. What I'm trying to do in this part, just to give you some idea about the key terms of blockchain. So cryptography involves the use of mathematical algorithms and techniques to encode and decode data, ensuring that it can only be accessed or modified by those who have the proper key or knowledge. Cryptography is a practice that has a long history, going back to the ancient civilizations. It involves the use of codes and ciphers to protect information from unauthorized access or manipulation. Throughout history, cryptography has been used for many purposes, such as securing military and diplomatic communications, verifying financial transactions, and maintaining privacy in electronic communication. So let us take an example to understand. Let us take an example, the Caesar Cipher. It was used by Julius Caesar to encode his communications. It said that Caesar would send messages to his officials using this cipher in order to protect the contents of the message from being intercepted and understood by enemies. To use the Caesar cipher, Caesar would choose a shift value, for example 3, and then shift each letter in the message by that number of positions. For example, if the shift value was 3, the letter letter A would be replaced with D. In this example, we have, for example, we want to send a message ABC. It doesn't make any sense, but we are trying to understand the idea here. And this can be done shifting the letter A's position in the alphabet by 3. When we do that, we get the value D. For B, we get the letter E. And for the C, we get the letter F. For an enemy, it's something completely different. And when the message is reached to other officials, they need to make it understandable. And this is called decoding. To decode the message, the recipient shifts each letter in the encoded message back by the same number of positions. For example, for D, they are going to make it A. For E, they are going to make it B. And for F, they are going to make it C. In this way, Caesar would communicate privately with his officials while protecting the contents of the message from being understood by others. Okay? Cryptography in blockchain and how it is used. Let's understand this. Cryptography is a fundamental aspect of blockchain technology, and it is used to secure and protect the data stored on the blockchain. It involves the application of mathematical algorithms and techniques to encode and decode data, ensuring that it can only be accessed or modified by those who possess the necessary key or knowledge. Cryptography performs a number of crucial functions in the operation of a blockchain, including verifying the authenticity and integrity of transactions, protecting data from unauthorized access, and preserving the privacy of users. So cryptographic methods used in blockchain. So there are several cryptographic methods, and we'll see most of them in detail. So you just need to get the idea. And we have hashing. This involves the use of a mathematical function to convert data into a fixed length string of characters known as a hash. I mentioned block hash in our previous video. We had a block header, and using the properties in that block header, we get a hash value by putting them into an algorithm called SHA-256. So this hash can be used to verify the integrity of the data, as any change to the data will result in a different hash being generated. So don't worry, I will explain this SHA-256 algorithm with its properties in detail. So digital signatures. These are used to verify the authenticity of transactions on the blockchain and to ensure that they cannot be altered. Digital signatures use a pair keys, a public key, and a private key to create a unique signature that can be used to verify the identity of the sender. I will also talk about public and private keys, so you don't need to worry about it as well. Public key cryptography, it's also known as asymmetric encryption, and I will talk about asymmetric encryption with its pros and cons in detail. So this is a type of cryptography that uses a pair of keys to secure communication. The public key is used to encrypt the data, and the private key is used to decrypt it. This is one of the most important concepts of cryptography, so that's why I will have a thorough explanation on this. So symmetric key cryptography, this is a type of cryptography that uses a single key to both encrypt and decrypt the data. The key must be kept secret in order to maintain the security of the data. For example, Caesar Cipher, right? We are using the same secret key. It was 3 for our example. So that's gonna do it for this video. I will see you in the next one.